Welcome students. As we have decided in the previous video, we will see a practical C program for different operations on linked list. So as per your manual, this is practical number 10, perform operations on single linked list. The practical outcome is write a C program to perform the operations like insert, delete, traverse and search on a linked list. So what are different operations we have learned theoretically in previous videos. Now practically we are seeing a program. Before starting the program, I would like to show you the output of this program so that it will be helpful for you to understand why to watch this video. If at all you are watching this video, go and watch the video till end. So I will execute this program. So here you are seeing a DOS window showing different options. I will increase the font. Okay. Now the program is very interesting. It shows different menus starting from 1 to 9. First option says create linked list. Second option says display. Third is insert at the beginning, insert at the end, insert at a specified position. Sixth operation is delete from beginning. Seventh one is delete from the end. And eighth one is delete from a specified position. All these operations theoretically we have learned in previous lectures. Now we will see practically how it actually works. So initially what we have to do, we have to create a linked list. So the choice will be 1. Whenever you say 1, it will ask please enter a data value for the node. In my case, the data value will be 10. When I enter, again the program is asking me the same options. Now once I have created the linked list, I would like it to be displayed. So when I press 2, I am choosing the option to display the linked list. Now the linked list is displayed. The option says, now the program says the list elements are 10 because there is only one element. Now what I will do, I will add one more element in the end. In the end means we have to choose the option number 4. Now the program is again asking me enter the data value for the node. What I will enter is 20. So now in your linked list there are two nodes. Earlier we have created 10 value, then now we have entered 20 value. So please check and display. So we will choose option number 2, that will display the list. Now it is saying the list elements are 10, 20. Now what I will do, I will insert at the beginning. For insert at the beginning, I have to choose option number 3 and press enter. Now again it is asking for the data value. I will give data value as 5. So your new node is created in the beginning. How to check it? Same, to display the list. When I say to display the list, it is saying that in your linked list there are three elements 5, 10 and 20. So in this way you have seen that how to create a linked list, how to display, how to insert in the beginning. So let us check whether your program works for insert at the end also by choosing the option number 4. Your program is asking for a data value. I will enter 40 here. I will display the list. Now the list is displayed like 5, 10, 20, 40. 40 is added in the end. So all these operations are working. What about delete? Let us check. Let us see whether your program deletes the first node. What was your first node? Let us display the node. Your first node is 5. Let us check whether your option number 6 is working or not. Option number 6 is for delete from beginning. That means after pressing enter and after pressing 2, that is display, it should display only 10, 20 and 40. That means 5 is deleted. Can we delete from the end? By choosing option number 7. When I choose option number 7, 40 should be deleted. Let us check. I will press 7 and again I will press 2. Now the list displays only 10 and 20. 40 was deleted because we have chosen the option number 7, delete from the end. Now delete from a specified position. I want to delete from the specified position number 2. So I will choose option number 8. It will ask me the position. The position is 2. Now only one item should be remaining, that is 2. That is 10. Actually your position is 1 because position starts from 0 actually. So I will press 8 and I will give position as 1 and now I will display it. So your first location element is deleted, so only 10 is remaining. So all of these options are working properly. When I choose option number 9, it is for exit, and the program will terminate. It will say press any key to continue, and the window get closed. So in this way the program works. How many lines are there in a program? So when I go to the end of the program, you will see how many lines are there. Total 294 lines are there. Approximately 300 lines of code is there in the program. So let us see each line one by one. In the very beginning, we have three lines. One is for including header files like stdlib for malloc and free, stdio.h for printf and scanf, conio.h. Conio.h for CLR SCR, that is clear screen. Now there are different functions. These functions are having return type as void. Now first function is create, second function is display, third is insert begin, fourth is insert end, insert position, that is insert after a specified position, delete beginning, delete end, and delete position, that is delete after a specified position. So these are the functions which you are going to implement, right? So I have just declared these functions. Now what I have to do, I have to create a structure. So here I have created a structure node. This is struct node in which there are only two variables. One is data and another one is pointer, which will be pointing to the next node, right? After that I have created our main pointer, that is head pointer. In this case I have taken the name as start. Start pointer will always point to the first node in your linked list. Initially there will be no node in the linked list, hence start will point to null, indicating the linked list is empty. Now your program starts from main function. Inside the main function you have to just set up the menu. For that I have a while loop. This while loop will continue always. That means while one means true. It will be infinite loop, right? But it will have a condition. At that condition the loop will break, right? What is that condition? The condition is when the user chooses to exit. Until and unless the user chooses to exit, it will not exit. The loop will not exit, right? So that will depend on the choice of the user. If user enters 9, then in this switch case 9 will be matching, and case 9 is nothing but exit function is there. Exit function says that your program will terminate, right? Your program will terminate. So let us see how many options I have given to the user. As we have discussed in the output, we have given different options to the user. For that you have to use the printf function. Inside printf I am giving numbers with option. So these numbers will be entered by the user, either 1 to 9. There are different options: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Ninth option is for exit. If user presses 9, the program will exit. So these options I am giving in the while loop, and after that what I am doing, I am taking the option of the user. That is, I am reading the option from the user. How I am reading the option from the user? By using a scanf function. Using a scanf function, the choice the user is entering, I am keeping it in a variable choice. The variable choice is of type integer and it is declared earlier in the starting of the main int choice. So this choice number will be matched in a switch case, and accordingly the function will be called. If the user want to create, he will choose the choice number 1. So case 1 will be matching and create function will be called, and after calling of the create function, case will be break. So hence there is a break function. ठीक है. Now case 2 is for display, case 3 is for insert beginning. Accordingly I have called all these functions and this will execute in a proper manner. Now if any of the user gives a wrong choice, then that will be catched in a default case, and in default I have written a printf message that your choice is wrong, and the case will be break. Switch will be break and your while loop will continue, right? So in this way the while loop is an infinite loop. Now we will see each function one by one. I think there is no need to explain all these functions because in detail we have seen in our theory videos how these functions works. Okay, so create function, how it works. So for creating, I use two pointers, temp pointer and ptr pointer. Temp pointer is a new node created by using a malloc function. And if temp is equal to null, it indicates that your RAM is totally full and there is no space in the memory. Such thing will never happen. But again, as a programmer, we have to think for this condition also. Your RAM is going out of memory. This thing will never happen, but again we have to think for this condition. So assuming all is right, then that node will be created and it will be pointed by temp variable, and we have to add the data. For that I have given the message to the user, please enter a data value, and that data value I am using in temp of data. So diagrammatically how it look like? Diagrammatically it will look like this. A new node is created in the linked list, and this new node will be pointed by a pointer called as temp. I will write in shortcut as T, right? So here the data will be stored in this line, the data will be stored and it will come here, right? Suppose I am entering 5, then it will be stored here, right? Getting thick. Then next of that node will be null, right? So here I will check that if it is the node first created, how to check that the node just created is the first node? By checking the start pointer. If start equals to null, it means that earlier the linked list was empty and this node is the first node created. Okay. If this is the case, then start should be pointing to the newly created node. If this is not the case, then we have to set a pointer ptr is equal to start, and we have to reach up to the end of the node by using this while loop. And while reaching the end of the node, we have to attach this newly created node. This is the case of insert in the end. Now let us see the display function. Display function, first we have to check whether your linked list is empty or not. How to check that? By using start equals to null condition. If your start equals to null, it is the condition, then your linked list is empty. Then if your linked list is not empty, then what happens? Then it will go to the else part, and in the else part what we will do? We will start from the first node. So ptr pointer, temporary pointer I am taking here, ptr is equal to start. So we are starting from the first node, and from the first node to the last node. So the condition is pointer is not equal to null. So I'm printing the data and I'm moving to the next node. How to move to the next node? By using the line ptr is equal to ptr of next. Okay. Now insert beginning. Insert beginning. How to insert a node in the beginning? Same. First you have to create a node, add the data, make the next pointer as null. Then what you have to do? You have to properly manage your start pointer, right? Start will be first temp of next is equal to start. So this node will be added, and then start is equal to temp. Only these two lines you have to keep in mind. Remaining logic is very simple. Then we are seeing insert end. Okay, insert end. Insert end, we have to reach to the end by using a while loop, right? By using a while loop, and you have to set the pointer as pointer of next is equal to temp, right? And that newly created node will be added in the end. Now insert after a specific position. For that you require two pointers, ptr and temp. Temp is for creating a new node and adding a data in that. After adding the data in that, what you have to check whether your temp of next is equal to if position equal to 0, right? If position equal to 0 means what? You are going to add that node in the beginning, right? For that what you have to do? You have to make temp of next is equal to start and start is equal to temp, right? Else what? Else you have to reach up to that position. For that I am having a for loop. For I is equal to 0, pointer is equal to start, and I is less than position minus 1. So pointer is equal to pointer of next. If pointer equals to null, that means position not found, right? If the position given by the user is such that it doesn't exist in the linked list. For example, in your linked list there are only 5 nodes and the user is asking to enter after 100 nodes. 100 nodes are not existing. So it is a wrong position given by the user. So in that case, this if loop will manage and it will give the proper answer as position not found, right? So if the position is not found, this is not the condition, then you will reach to the proper position, and these two lines will manage the links of the node. After that, delete begin. How to delete the beginning node, right? We have seen in the theory lecture by setting the pointer properly, right? For that, what you have to do, you have to take a temporary pointer ptr, and you will point to the first node, and that first node will be moved to the that first node now. Sorry, temporary pointer ptr will be pointing to first node, and start was pointing to the node, it will be moved to the next node, and after that this temporary pointer will be deleted. So delete end, you have to reach up to the end, and you have to reach up to the end or previous of the end. For that you have to take two pointers, temp and ptr. So what I am doing is ptr will be at the start, and then what I am going to do is start. This is the case if there is only one node, right? I am assuming that in there are more than one nodes, right? At that time what will happen? See, I will draw a diagram. Suppose in your linked list there are three nodes. Now in your linked list there are three nodes. To this pointer start is pointing, I will say yes, and to this pointer temporary pointer ptr, I will say p is pointing. Now what will happen? P is pointing to this due to this line, while ptr of next is not equal to null. Whether the next is null? No. So ptr be moved. Ptr is moved. Whether the next is null? No. So ptr will be moved. Whether the next is null? Yes. Now this while loop will stop, and your p comes to this position. Right? I will erase this. Your ptr will be pointing to this node. Now temporary pointer of next is equal to null. Right? Temp of next is equal to null. Now what happens? Temp is pointing to ptr, right? So this is your temp, right? This is your temp. So what I does is here I make a null. Here when I make a null here, then this link will be deleted. So this node is totally free now. It is isolated. Instead of saying free, I will say it as a isolated. So whenever this node is isolated, at that time what happen? This node can be freed by using a free function. So in this way the delete at the end logic works. Now the last function remaining is delete position. Delete after a specified position. For that what you have to do, you have to take two different pointers, right? Temp and ptr. Okay? You have to first check whether your linked list is empty or not by just checking if start equals to null. After that you have to read the position after which the user wants to delete the node. So once you read the position, it will be stored in a POS variable, and if you again you have to check whether his user is entering the position as first node, right? So if position equals to 0, then what will happen? That means the first node is to be deleted. So what I will do, I will take a temporary pointer ptr start, I will store in there. So ptr will be pointing to first node, and start I will move to the next node, and I will delete the ptr pointer. Okay? If this is not the case, then what you have to do, you have to again start from the first node. So temporary pointer will be pointing to first node, and up to the position you have to move pointer variable, right? Up to position, right? Including position I am not saying, excluding position. Okay? Suppose for example you want to delete a node after second node, and there are total, you want to delete the second node, right? This node you want to delete, and there are total three nodes, right? So your ptr is starting from this point, right? So the condition is I is less than position. The position is, this is zeroth position, this is first position, right? So this node you want to delete, right? And this is third position. Okay? Now this node you want to delete. Yes. Now ptr is equal to start. P is pointing to this node because start is always pointing to the first node. Clear? Okay. After that temp is equal to ptr. So temp is also pointing to this node. Okay? After that ptr is equal to ptr of next. P is pointing to this node. Okay? Now this I will erase because P is not pointing to this node. Okay? Okay. If ptr equals to null, no. Then printf position not found. This is not the case. Then what you have to do? Now just you have to make the link like this. This is temp. Temp of next is equal to P of next. Right? Here the code is written here. See here. Temp of next is equal to ptr of next. And now just you have to free the ptr pointer. So the node will be deleted. Right? So I have tried my best to explain the topic. The topic is hard. So how to learn this topic, right? Whenever you observe that the topic is a bit tough, you observe the video lecture and you follow me, right? What you do, you whatever I am saying, you just repeat it in your mind. Repeating my words will make you understand the concept easily, because these concepts are really tough. But again, you have to learn by heart this concept. So the better way to learn these tough concepts is that whatever I am saying, you just repeat in your mind, and please watch the video till the end.